MS Ramaiah University of Applied Sciences.
Hi students, let us discuss the experiment on digital to analog conversion using IC MU-A741 to design and study the performance of digital to analog converter. The design of the digital to analog converter is as shown here. The input given to the circuit is in binary bits and the output in terms of voltage is measured. The circuit diagram and tabular column is as shown. The binary bits presenting in the table is treated as input and the output terminal is given to voltmeter to measure the voltage for the corresponding input bits. After taking the readings, plot the graph and observe the analog formation from the digital input.
Dear students, today I am going to explain the study of digital to analog converter circuit. So we have one study experiment here. So the aim of the experiment is to analyze our MU-A741 IC, whether it may be working for the digital to analog converter or not. So what are all the components that will be required for this experiment is, so one is digital trainer kit. So first I am going to introduce about this logical input. So this is the logical input. This logical input gives the digital output to the circuit. So hence we can use the digital bits as an input for the building circuit. Next I am going to use this circuit board to build the circuit based upon the circuit diagram. Next I am going to use this power supplies, 12 volt power supply VCC I am going to give from this point. So I need to make this as a common ground from any of these points that will be connected to common ground. Multimeter I am going to use in this circuit to measure the output. It will show the analog values at the output terminal. MU-A741 IC, so it is an 8-pin IC. From the left hand side we can count the values of this terminal 1, 2, 3, 4, 5, 6, 7, 8. 1 kilo ohm resistors, 4 1 kilo ohm resistors I am going to use in this experiment. 2.2 kilo ohm resistors, 6 2.2 kilo ohm resistors I am going to use in this experiment. And the connecting wires. Now I am going to start the circuit connection based upon the circuit diagram. Now I am going to place the IC MU-A741 on the circuit board. So first I am going to short the pin number 2 and the pin number 6 the circuit. This is pin number 2 and the pin number 6 I want to make it as short. This is pin number 6. Now I am going to connect this 2.2 kilo ohm resistor to terminal number 3 to the ground. So this is terminal number 3. This will be connected to ground. I made somewhere in the outside of this board is ground. So this is ground connection. Now I am going to connect a 1 kilo ohm resistor from the terminal number 3 to one end of the point. So terminal number 3 to one point somewhere here. Next I am going to take the 2.2 kilo ohm that will be connected between the terminal 3 to somewhere in the point. So connecting this 2.2 kilo ohm to somewhere in the point, I am going to connect like this. I place this into here. Next I am going to take 1 kilo ohm. So I place that 1 kilo ohm in between the 1 kilo ohm resistor of other to another end like this. Next again I am taking 2.2 kilo ohm. I place the intermediate nodes that will be present in the 2 junction and to the point somewhere in the circuit board in the next level. Likewise I need to continue. Again I am taking 2.2 kilo ohm resistor. I place this 2.2 kilo ohm resistor with other terminal like this and to somewhere in the point. Next I am taking 1 kilo ohm resistor again I placed somewhere in the point here to here. Next I am taking 2.2 kilo ohm. I will connect from here to somewhere in the point like this. Next I am going to connect again 2.2 kilo ohm resistor with the point from here to the ground. This is the point. Again I need to connect this into ground. I made this as ground. I want to short the two grounds that will be connected in same line like this to here to here. Next I am going to connect the digital values or VCC. First I am going to connect VCC, so positive end plus VCC, that will be connected to pin number 7. So this is pin number 567, this is pin number 7. I am going to connect here. This is the pin number 7. Next I am going to connect the negative end to pin number 4. So this is pin number 4. I am going to connect here. This is pin number 4. Next I am going to make the ground connection common. So I made ground connection common by using this terminal. And by connecting this point to somewhere in the point like this, it makes us common ground. For checking the output, so I am connecting multimeter. Take the multimeter and place the wire to positive terminal and put that positive terminal to pin number 6, because 6 is the output terminal. So this is pin number 6 I am placing here. So negative terminal to the ground, negative terminal to the ground. So this is the ground connection I am placing here. So to connect the digital inputs, I am taking the wires from here. So this is the digital logic digital inputs I am going to give to the circuit. So I connecting the same point like this. Next I am taking another wire to connect the another port from here to here. I'm taking another wire and I'm going to connect this wire from here to another junction point to give an input is this point. So I'm going to give here. Take another wire. So you place that wire like this here to the another bit what we are given at the input. So this is this junction, so I am going to connect here. This completes the circuit connection of digital to analog converter. Now I switch on the digital IC trainer kit. All values of digital value will be 0 0, it will give the analog value 0.0. So now I am going to increment these values from 0 to 0 0 0 1, so it will give some value 0.9. Next I am going to give the value of 2, that is 0 1 0 0, it will be incremented to 0.4. So every time it will be incremented to 0.2. Now I am going to give the value of 3, that is 0 0 1 1 I am giving, it will be incremented to 1.5. Next I am going to give the value of 0 1 1, it will be incremented to 0.9. So next I am going to give 1 0 0 1, it will be incremented to 1.0 or 1.09. So next that will be given 0 1 0 1, it will be incremented to 0.5, decremented to 0.5. Next I am going to increment this one to 1 1 0 1, it will give 1.6. So next I am going to increment to 1 1 1 1, it will give 2.05. So what we are concluded here, so if you raise the values of digital bits, it will gives a simultaneous variation in the analog output. So we can plot these values, digital values, with respect to analog output, so we can get a one complete curve. So this curve indicates the digital value that will be converted into a analog one. So hence we can conclude our operational amplifier MU-A741 IC that can able to work as an digital to analog converter. This completes the experiment of digital to analog converter.
At MSR UAS, we spark